Hello, welcome to everyone. In this video, I would like to explain what is Coulomb's law, what is its statement, and how it will be useful to find some important entities like forces. Okay, before that, we have learned there are two types of charges, positive charges and negative charges. And we know that the positive and negative charges always attracts each other. We have learned in a line like charges repels each other and unlike charges attracts each other. Now, how do you find out the force of attraction between two unlike charges? Do you have any idea how to find out the force between two unlike charges? Unlike or like charges, whether it is force of attraction or force of repulsion, that's not a problem. How we can find those things? We can use Coulomb's law as the tool for calculating the forces between the charges. The statement is very simple. The statement of Coulomb's law is that the force of attraction or repulsion between any two charges, whether it is attractive or repulsive, can be calculated by using the Coulomb's law. The Coulomb's law, again, the statement is the force of attraction Hello, welcome to everyone. Today I would like to explain what is Coulomb's law and what is its statement and how it will be useful. Okay. We have learned two types of charges, positive and negative. And we have learned the like charges repels each other and unlike charges attracts each other. Okay. The force of attraction or repulsion can be calculated by using the Coulomb's law. Okay, the Coulomb's law states that the force of attraction or repulsion between any two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between the charges. Okay, now let us consider two types of charges, Q1 and Q2. Suppose they are separated by a small distance r, then according to Coulomb's law, the force of attraction or repulsion, that depends on the nature of charge, is directly proportional to the product of their charges and inversely proportional to the square of the distance between the charges. Q1, Q2 by r square. This is Coulomb's law. Okay, so if the magnitude of the charges is known and the distance of separation is also known, we can calculate the amount of force between the charges. Okay, now we are going to equate the proportionality by multiplying with a constant k, and F is equal to k into Q1 Q2 by r square. We have known the value k is equal to 1 by 4 pi epsilon 0, where pi, pi is equal to 3.14, and epsilon 0, this is known as the permittivity of free space. It has a constant value as 8.854 into 10 raised to minus 12 Newton raised to minus 1 and Coulomb square meter raised to minus 1. So this is a value for epsilon 0, 8.854 into 10 raised to minus 12 Coulomb square Newton raised to minus 1 and meter raised to minus 1. Okay, now this is the representation of the Ohm's law, that is representation of Coulomb's law, that is F equal to 1 by 4 pi epsilon 0 into Q1 Q2 by r square. This value can be calculated, that is 1 by 4 pi epsilon 0 equal to 9 into 10 raised to 9 Newton. Okay, we have learned the statement for Coulomb's law. Again, repeat, the force of attraction or repulsion between any two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between the charges. Since the force is inversely proportional to the distance, this law is also known as inverse square law. Okay, so this is the final equation for the force between the charges, that is F equal to 1 by 4 pi epsilon 0 into Q1 Q2 by r square, where 1 by 4 pi epsilon 0 is equal to 10 into 9 into 10 raised to 9 Newton. Okay, now we know the force is a vector quantity, right? The force is a vector quantity, so we need the direction to represent this one. Suppose this one, this the force is from q1 to q2, therefore we can write the distance is r1 to r2, so this is a vector quantity, so we can modify this equation as f equal to 1 by 4 pi epsilon 0 into q1 q2 by r square into the distance is r12 square, therefore r12 square into the unit vector from q1 to q2, that is as r1 to the unit vector. So this is a vector representation of the Coulomb's law. Okay. Now, how do you find out how this law is effective in a system particles? System means it can, suppose the system consists of more than one particles, more than two particles. Suppose this is the case. Suppose this is charge 1, this is the charge 2, and this is charge 3. Then F equal to F12. F12 is the force between 1 to 2, and F13 is the force between 1 to 3. Therefore, F equal to F12 plus F13. F equal to 1 by 4 pi epsilon 0 is a constant, so it can be taken outside. 1 by 4 pi epsilon 0 into Q1, Q2, R12 by R12 square, right? Plus Q1, Q3 by R13. R13 is a unit vector, right? So this is the representation of the force in a system of charge particles. Hope you understand the basic concept of Coulomb's law. Thank you.